screen is visible, the slide.
Yes, sir.
Yeah, it's visible.
It's
Oh,
visible.
Yes, sir.
okay, perfect. So let's start with today's introductory session all about data science. Basically, data science and data analytics. Later, you will know that data analytics basically is a subpart of the data science. Like the bigger picture is data science. If you go inside, then the analysis part gains. So now the first thing, like what is data? Like you must have heard something like data is everything, data is the new oil. We need to be very particular about the data privacy is like one of the trending stuff that you can ever think. But the reason is like what is data and why we need to take care, like why we need to bother about this data so much. Can anyone answer it, like what is basically a data? Anybody likes to try?
Information.
um you are close, but data is not exactly information. Okay, anyone
Collection
else?
of information.
Collection of information. Okay, okay, fine. Anyone else wants to try? Yeah, hello, yeah, Sohail.
Sir Manish, it is a raw
Yes, Mani?
material of information.
Raw material of information. Okay, so one thing that probably all of you are saying that information. Let me tell you, information and a data is different. Okay, this is way different. Like there's a very you can say like a very common question. What is the difference between an information and a data? Okay, so information is something that has meaning. Okay, like if you have an information, like whatever I'm speaking to you, this is, you can say, information because it has proper meaning, it is well structured. Okay, but data is not necessarily to be to have a meaning. Okay, like you are getting, let's say, if you use like Zoom, like if you are familiar with this Zoom thing, like Zoom has an attendance stuff. Okay, so we need to take the attendance as like the attendance data, and this is known as attendance dump. So this is also comes under data, but it doesn't necessary that that particular data have proper information. You can collect data, you can refine it, and you can make extract information from. Okay, so data basically is the raw material, and if you play with data, if you try to manipulate data, if you try to do the sanity of the data, then you will get a lots of information. So remember, this is the basic difference between a data and an information. I hope I'm clear. Anyone has any question regarding that? Okay, seems like fine. Okay, so now the thing is like the data. Okay, so we say like we have this data, we need to generate this data, we need to collect that data from. But can anyone tell me like what is the primary source of like any kind of data? Like data we can get from multiple sources. Like, but what are the couple of primary sources that we get the most amount of the data? Can anyone say that?
So can I answer?
Yeah, sure.
Sir, let's take an example of e-commerce company like we have DMart also, IndiaMart also. So many people come over there for the shoppings, and then after that, the person scan the products, and then after that, they just make a bill. So that is the first place. So we can get to know that how many customers are purchasing or buying that products. That is the initial level. We get a data from it, and then after that, according to me, we analyze and whatever all.
Yeah, perfect. Like this is the e-commerce industry. Like this is the exact way we
Yeah.
get the data.
Yeah.
Perfect.
Yes.
So any other example? Like if I give you for example, I need a healthcare data. I need data regarding, let's say, regarding some medicine, or I need some video data. I need some audio data, right? I need some data which is probably in the electrical signal. So there are multiple sources that you can get the data. Basically, if you consider the medical field, like you have seen those like really small machines that actually use for like for the sugar testing, some then that clip that can that can measure your heart rate and all the different stuff. These are also data that is stored somewhere, and those data we can use it. We can put it in a ML algorithm, and we can really predict some interesting stuff. So the data, we have huge amount of data, and each second a huge amount of data is generating. So there is no shortage of data. Okay, but what is the challenge that comes when we have data in this much volume? The thing is the how we can maintain it, how we can store it, or how we can put it structurally so that we can use it as per our convenience. And there is a biggest limitation that comes with it. Can anyone tell me? Like, just use your common sense. Like, when a particular thing is generating in a very huge quantity, what is the very possible challenge or possible disadvantage that also comes? Anyone wants to try? This is not with data. It basically with each and everything.
Security of data.
Sorry.
Security of data, whether it can get leaked.
Yeah, security of data is definitely it's a challenge, but there is a bigger challenge also.
Storage.
Storage, we have enough storage. We have cloud that can like literally store infinite number.
Authorization.
Authorization. Okay, so you are actually thinking about the security stuff. So just describe the security part. Okay, you have a big data. So now the thing is, what to do with the data, right?
Get it into a structured form.
Yes. Now, like Avi, he said about e-commerce data. So let's say like someone belongs to the medical industry, and I'm giving him the e-commerce data, and I'm pretty sure that he won't understand even a part of the data. So the big thing is the relevance. Like like a machine is generating or something is generating a huge amount of data, but how relevant is it for myself? Like if the data is not relevant, then for me it's a noise data, it's a garbage data, and I don't want to keep it with me, right? So this is also a challenge that to identify which data we need and which data we don't need. So this is like one of the challenges. We will discuss about more on the pros and cons part. Okay, coming to the next slide. Now again, this picture again says the security part. Now this thing we need to know, and also we need to understand that why we need to secure our data. Like when I came at the very first time, like in this data science, I always had a question. Like, okay, like I need to save my, let's say my Facebook credentials, my Instagram credentials, and other like my email, like password. These things I need to save. But like the larger data, like let's say I'm generating 1 GB of data every day. Like why I need to bother about that data? Why I need to care about those data that is not even needed. And if a company is taking that data, then what is the problem with that? So this was my question very previously. So just think about it, and can anyone answer? Like let's say I am taking your daily activity data from you, which you don't need. I'm just taking it from you. Then what is the threat? Or is it legal, or is it a legitimate thing to do? Anyone wants to answer? Is my question clear?
So can you just please repeat the question one more time?
Yeah, the thing is, let's say you are generating 1 GB of data every day. Okay, in various activity. So if I say you that give me the data, so and you are giving it to me, so is it like a legitimate practice, or is it a good, or do you have any security, any threat regarding that? What do you think?
Yes, sir. So if we are not
Yeah, one
securing
minute.
it, someone may access our data. So it becomes illegal then.
Yes, definitely it's
Yeah.
become illegal. But the thing is, like, why it's illegal? Like the data, something, this is something that I don't need. Okay. So if someone is taking, like, then what is the threat? Like, what are the possible kind of threat I might face? Can you tell me?
Someone who is collecting the data, they might misuse our, I mean, whichever the data collected.
Yes, definitely. Any more? Anybody
So,
wants to try? Yeah.
sir, but according to me, clearly we cannot say that it's a means it's a illegal, because actually yesterday I was reading a one story. So actually there also there was a one person who was just collecting the data, those
Mhm.
customers who were just visiting to the hotels, and then after that they were using it for the digitalized advertisement and whatever, and they had a huge profit also. So from that example,
Uh, I guess, sorry, we can't hear you, Abhishek. Okay. Okay, so I have understood that, yeah, like the data, like whatever data we are generating, like it is very personal to us. Now, why I'm saying that? Because I guess everyone use a smartphone, and every smartphone right now we have a voice assistant. It must be Siri, it must be Alexa, it must be Google. Oh, shit. Sorry for that. So it must be something else. Google Voice Assistant. Now see, whenever you take like its name, for example, when you say "Hey Siri," it activates, right? It activates means it is actually getting my voice there, and it is recognizing. So try to understand whatever you say every day. That means your phone is listening. Your phone is listening each and everything, and when you tell, like, for example, "Hey Siri," then it's responding. So in other words, what I'm trying to say, that your phone is actually getting the data 24 into 7, with it, which you don't even know. For example, you are making a conversation with your friend, like, probably I need a brand new TV, I need a new, like, a new laptop, and yeah, you might see that when you turn on your phone, that and if you go to Amazon or Flipkart, you might see that there is a TV that is in a discounted price. There is a phone that is discounted price. This is a proper recommendation engine. Now, this recommendation engine needs this kind of data which we use in our daily activity. Now, this is a good thing, but the bad thing is we speak a lot. We speak a lot of things, very confidential thing, very personal thing, that we don't want to share with any third party. So that's why the data security is very important. And whatever we say, we need to make it personal to maintain our privacy. We need to bother. We need to bother really, like, very much about this, the data security part. And we need to, we need to read those terms and conditions when you are buying a smart device, and also a smart speaker like Siri. Okay, so this is a part that I really want to highlight, that our data is very, very precious and very, very important. So that's why there is a phrase that data is the new oil. Okay, so let's jump to the data science, like the history of data. So in this picture, like you can just check like how previously we gathered the data. Like if it's come to the historical data, like a very ancient history, we only have the transcript. We might have the sculpture, and from that we can gather data. And time to time, like when the newspaper comes, the article and all the stuff comes, then we like the source of that data were like increasing. And right now, like basically every thing, every machine, when it comes to the electronic machine, every machine generates some data. And if it's like relevant, we can definitely use it and we can make wonders. Now, the thing is like, what is data science? So basically, like we have a huge amount of data. Now, what to do with the data? Like basically, the source of the data science is take the historical data, process it in some way, and create some prediction. Like what kind of prediction? Like something that might help to make our decision better. Let's say I need to decide something like, let's say I need to buy a laptop. So which laptop I need to buy? Which one I need to like consider on my budget, on my requirement, and also depending upon a lot of stuff. So this is one example. The one of the trending example of this, that stock market prediction, like the stock price. You need a proper prediction that whether the stock price is increase or the stock price might decrease. These things we can actually do. We can create this kind of projects by the help of the data science, or very specifically this machine learning for prediction. Okay. Now, yes, this is the very important the data science lifecycle. Although if you Google it, you will see a various version of data science lifecycle. And let me tell you, everything is right. Data science lifecycle is something that you can't actually put it in one particular diagram and one particular picture. Depending upon your use case, depending upon your user story, you might need to perform a particular step probably multiple times, or probably one time, or you might skip it also. But this is the like a overall standard thing, like standard way of data science life cycle. So it starts with this business problem understanding. Generally, like you have a problem, you have something, you have identified a problem in the market, and you want to create a project accordingly. That, let's say you want to create an app and create a proper software. For that, you need like a problem, a business problem, definitely. Then the second part is the data collection. Let me use my template. Yeah. So once you have understood the business problem, then you need to collect the relevant data. So remember, you can collect many data, but find the relevance of the data is a bigger job. And this is actually this thing, like preparation of data. This is a like a fundamental job for a, so for that fundamental thing for a you can say data engineer, because the data engineering basically does this part. It actually takes the data and find the relevance, make it in a proper like a set, for example a CSV file in a tabular structure, and put it and proceed it for the next step. So definitely the data collection. Once you have the data, now you again need to do the cleaning and the data preparation. Now this cleaning is needed for a particular use case. Let's say you have a business problem, and to solve the business problem, you have multiple use cases to solve it. Okay, just please give me a minute. I need to take a call. Okay, yeah, sorry for that. So yeah, so we were in the data cleaning and data preparation. So why this step is needed? Again, for a particular use case. Let's say your business problem has 3 or 4 use cases, and for each use case, yeah, you need a different kind of data. but you have your database, which is over here. So for that, you are taking a particular chunk of data and you are cleaning it, and you are making the data to push into the next step. Now, once you have a data for your each use cases, here the comes of the part of a data analyst, that is exploratory data analysis. Now, this part, like you must be thinking, like we have the data, we already know how the data looks like. We can see all the column names. We can actually see each individual data in each like each cell. Then why we did this like EDA part, exploratory data analysis part? So the thing is, exploratory data analysis is all about the data visualization, like how you have a data, but you need to take a like a visual look by using different kind of charts and different kind of like diagram, or if you use a software, for example, Tableau or Power BI, then you can create a dashboard. By looking at the dashboard, you can actually think, and you can predict in your mind that how that like the situation, or for example a graph will be moving after this time frame. So a dashboard basically a collection of different kind of graphs there with a very meaningful thing. So that, let's say, in a dashboard basically looks something like this, where you have a different kind of chart here. Let's say different, here is a bar chart, here is the pie chart, here is a histogram. There are different kind of like chart that is available. We will speak about in the EDA section. So this is all about the data analysis part. And this part is very much important because, for example, let's say the business problem, let's say some a customer gives us a business problem and we need to solve it. And also customer needs to know like each and every step that we are processing. For example, data collection, data pre-processing. So this visualization we can directly show to the customer, and we can create some decision depending upon like how the nature of the graph, and how the graph is increasing or decreasing, or basically like depending upon the future prediction, because this EDA part also gives us a basic kind of prediction, let's say for a future time frame, for example for after 1 month, how the graph will look, how for example let's say in the stock analysis, stock market, what will be the particular price, let's say for after 1 month. This kind of small prediction we can actually get by using this EDA section. Okay, let me take a pause and let me ask you, up to these 4 steps, is it clear? Or if you have doubt, please ask me. Okay. So I'm hoping that everything is good.
Sir,
Yeah.
Manish.
Yes, Manish.
Sir, can you explain, sir, once again exploratory data analysis?
Exploratory data analysis is nothing but creating a different kind of graphs by using the cleaned data that you have done this data cleaning. We need to create a different kind of graphs with the data to analysis, to understand the data in a better way. This is the one-liner thing.
Sir, I have a
Yes.
question.
Yes.
Sir, data analysis by how we can create a data analysis report, right? Any other tools like Power BI?
Yes, so we can definitely do like Power BI, Tableau, like we have Snowflake also. There are multiple tools available for data analysis. So once we have the data, like the proper data, we can easily create it. We can put, we just need to know like which row we need to consider. We need to put it in the x-axis and the y-axis, and we can create it. Like this is the basic way of creation. There are multiple stuff. Like I hope that answers your question. Okay. Any more questions? Okay, cool. Now, once we are done with this exploratory data analysis (EDA), now it comes to the feature engineering part. Now, slightly, we are going to this machine learning modeling phase. Basically, we are entering to the artificial intelligence stuff after this exploratory, once the exploratory data analysis are done. So now, what is a feature engineering? The engineering just leave this word for now. Concentrate in this the feature. Feature means we can also say the feature column. So for example, in this data cleaning or the data preparation, we have, let's say, 100 columns. Okay, let's say we have 100 columns that we have identified that these are important. And we have done the EDA on it, and we got amazing stuff. Now, after EDA, we might find out that all these 100 columns, we actually don't need all these 100 columns to pass is it in the machine learning algorithm. We might think that probably from this 100 column, 20 columns are completely irrelevant in terms of prediction, in terms of machine learning prediction. Now, how you find it, that we will discuss later. But let's say you have found out these 20 columns are not needed. So what you can do, we can drop these 20 columns and we can proceed with the 80 columns to the machine learning like modeling part. So basically, this is the job of the feature engineering, like in a nutshell, you can say that we need to identify the important feature from the data. For example, a very common thing that we do from EDA to feature engineering, that the ID column. So every data set has an ID column, like for ID number 1, ID number 2, up to ID number, let's say whatever the last row was. So every data set has an ID column, and what we need to do before passing into the machine learning modeling, we need to drop this ID column, because this ID column doesn't have any relevance with a particular product. Because ID we use to identify a particular a row or a particular thing uniquely. But when we need to pass into the machine learning algorithm, we don't need to identify like a thing particularly. Like this is we do for ourselves. So for this reason, ID column becomes a noise data for the machine learning model. So we need to remove it. So this thing basically identifying of features are done into this feature engineering step. Okay, so feature engineering must be very new for everyone. So anybody has any doubt?
Sir, repeat, please.
Okay, feature engineering, right? So feature engineering, once let's say you are done with the exploratory data analysis, once you have the data, you need to identify that which data is more important for me and which data is not important. Which data is a noise data, which data is more important, and which data is less important. These things you need to find it out in this feature engineering step. That's why feature engineering is very, very important. Because if you don't do that, if you pass with the noise data into this machine learning modeling, your model evaluation would be very less. Model evaluation means basically the outcome of a machine learning model. It will be very noisy because you are actually passing the noisy data. So you need to identify the proper features. Feature means which column is important, which column is less important. These things we need to find it out. This is a very I can say very hectic part to do. And there are multiple algorithms, that is inbuilt algorithms are out there, and you need to think, and depending upon your user story or use case, you need to create different features. So basically, this is a very hectic thing. Okay. So anything else? Any more questions? Okay. Now let's proceed to the machine learning, or we can say machine learning modeling part. Now, machine learning modeling, that actually gives us different kind of models, different kind of machine learning models. What the primary job is to take the data and predict the like the future data depending upon the past. So machine learning models are very like the fundamentals are the statistics. It's actually based on the basics of statistics. You like some of you must have heard like something called linear regression, logistic regression. These are some statistical models that are used in the machine learning. And after that, we have different kind of regression classifications. We have supervised, unsupervised machine learning models. We will like discuss in that machine learning part. So in this machine learning modeling phase, we need to pass the data that we got from the feature engineering step. We need to pass it, and this machine learning model will give me some prediction. Now, it will give me some prediction. Now, let's say, for example, I'm saying that, okay, I have this data and I am getting this prediction. But this prediction needs to be validated. How I came to know whether my prediction, my machine, whatever is predicting, is it good or not? Probably, let's say my prediction is yes, and my machine is predicting no, which is completely opposite. So for that, we need to perform this model evaluation. This model evaluation is basically where I am validating my prediction with my existing data. So once this prediction is done, then again we do a basic of data visualization. Now this data visualization is very, very different from this EDA, okay, explanatory data analysis. This data visualization, what we do, we got our like a predicted data, and we also have our actual data. Okay, so this is actually a comparison between this predicted data and the actual data that if we put it in the chart, then this data visualization comes. Okay, now all of you must be thinking that if I'm predicting the future data, then how we have the visual, how we have the actual data present, because this is the future data. So basically what we do, when we pass into the machine learning model, let's say this is our whole data set. Okay, this is our whole data set. So what we do, we take probably 70 or 80% data. We pass basically 80% data into my machine learning model. Okay, and this 20% data is basically hidden from my machine learning model. So with this 80% data, we do the model evaluation. Now, once we have the our machine learning model ready, then after that, we pass this 20% data into my machine learning model, and we get an output accordingly. Okay, so basically this 20% data, this is my actual data, and whatever this 20% data, my machine learning model will give the outcome that is my predicted data. And here what I'm doing a comparison between actual data and predicted data. And this part of visualization, we also like put it in chart so that we can understand better how my model is working. Because in model evaluation, we might get a 90% accuracy. Okay, but we can see like in the data visualization part, which time this 90% accuracy might getting less. Let's say 90%, after some time it's becoming once we can see that it's becoming more 85%, 80%. That might possible. So for this reason, we do this data visualization part. And again, if this data if it's giving me my satisfactory result, again we need to go to the business problem, and we need to take make a set that whether this use case is completed or not. If this data visualization, this part is not giving me what I want, it's not giving me the answer, then again we need to understand the business problem. We might need to do a little bit changes in our database. Again, we need to do the preparation, we need to do the proper EDA, feature engineering, machine learning modeling, model evaluation, and again comes to the data visualization part. So this is basically a cycle. It will only end if my data visualization, this outcome is exactly matching with my business requirement. If it's a perfect match, then only we can stop this life cycle over here. So this is the whole, basically the data science life cycle. So any questions till now on any part? Any particular part is not that clear, please?
Can you explain the example like Excel database?
Sorry, I can't. Your voice is very breaking. I can't hear that.
Sir, can you explain it with example like Excel database and you can
Yes.
perform this type of.
Yes, definitely. See, Microsoft Excel is a you might have a data, and you can do a little bit of exploratory data analysis, a little bit of EDA, data visualization part by using Microsoft Excel. But if you want to perform this feature engineering, machine learning modeling, model evaluation, and also this visualization, you need to come out to the Excel, and you need the proper software. Like the industry standard software is the Jupyter Notebook. Basically, the software name is Anaconda Navigator. Anaconda Navigator comes with Jupyter Notebook. It comes with Spider, or also you can use PyCharm. There are multiple softwares, and all these things are really interesting name, like Anaconda, Spider, kind of stuff. But only using Excel, you can actually do up to this EDA part.
Okay.
Okay, perfect. Any more questions? Any more things? Okay, so let's move to the next slide. Yeah. So why data science is important? We already discussed basically the same thing, like why data is important. So definitely, let me give you a brief here. So data is definitely a very precious asset, and the day-to-day life, these things like Facebook, voice recognition, these things, fingerprint recognition on the mobile phone, these are the biggest application of the data science. Basically, the face unlock a system that every smartphone right now using, that is object detection, and that is also comes under the data science, in particular the machine learning, and if I more specific, it comes under computer vision. Like machine learning has different stuff: deep learning, computer vision, natural language processing. So all these things are data science use cases. So okay, so now let's discuss about the tools or the skills that we require to be a data scientist. So for the first and foremost thing that we need the Python. Now, this is an advantage in the data science world, that you don't need to know 10 different languages. If you know Python and really well, this is enough for your data science work, data analysis, data science. This one Python is enough. One more language that you need to know, that is SQL with it, because if you want to retrieve the data for that, you need a good SQL understanding. And with that, you need a Jupyter Notebook. Jupyter Notebook, as I said, it comes with the Anaconda Navigator, or you can install it separately, but better you download the Anaconda Navigator and you install this Jupyter Notebook. And the same thing you can also do with the Google Colab. So for Jupyter Notebook, you need to do installation, and but for Google Colab, you can completely do it on cloud. You don't need any installation. Google Colab is free at a certain point. Like if you need a higher RAM, higher graphics, then yeah, you need to pay. But like the basic things, even intermediate projects also, we can easily create by using Google Colab. Colab means basically Google Collaboratory. And we need to know Python libraries as well. So this Python is all about code Python, and Python are very rich with the libraries. So Python, if you compare with the other programming language, for example, C, C++, Java, let's compare with Java. The biggest difference with the Java and Python about this libraries. Java doesn't support machine learning libraries, or it has very minimal number of machine learning libraries or data science libraries that you can find. Python has the biggest number of like machine learning or data science libraries that is found. So if you are familiar, all of you are familiar with very basics of like the coding, like very basics of coding, you might know what is an array or what is a list or what is, for example, you can say object-oriented programming. So for this, Python is already good. Now, this object-oriented part, it actually enhance with this Python libraries. It makes our life easier, it makes our works easier, and these Python libraries are very fast. Some of the data science libraries that you can mention, that is NumPy, Pandas, and some of data visualization libraries, we can also use something called Matplotlib, Seaborn, Plotly. These are used for data visualization. Means we can literally create graph from writing code. And also we have MySQL. Definitely, like you will start this Python coding only if you have the data. To retrieve the data, you can use MySQL. MySQL basically a database, and we have multiple like a database, tons of database. We have different kind of relational databases, and you need to gather the data from it, and then we can start with the coding part. So these are the mandatory skills that every data scientist must be needed. Okay. And again, this is the skill set. So basically, it's first it starts with the teamwork. That so yeah. So again, data science is a collection of multiple, you can say multiple skills, definitely. And in order to work with all these skills, we actually need a team to work, because not everyone is as good as database, as good as Python, as good as like machine learning modeling, natural language processing. Not like everyone, like if you want everything in a single person, it's very difficult to find. So definitely teamwork is a very fundamental stuff that we need to go. We need to know about the Python, the core Python. We need to know about the data visualization part, and data visualization we can actually do a little bit by Microsoft Excel also. We have way better softwares that we can use for that. And also we need to know the statistics very well. So for the data science, for machine learning modeling, we need to know the statistics very well, because the fundamentals are lying on statistics. So basically, it is also comes under the high level math. High level math, that doesn't mean that you have to be expert in every mathematics, every mathematical thing. So basically, the machine learning things need the statistics and also the probability. So the probability chapter, hope you can recall from the 10th or 12th. And if you are an engineering background, then you have like the math papers. We have 2 or 3 math papers. So probability, statistics, these things are needed to run, to understand a machine learning model in a better way. But we don't have to be expert. Like we don't need a PhD, or we don't need a really expert. We don't need like months or months time. We don't need to put it in after maths to do it. We need to pick the relevant part that is needed. Same for the statistics also. And we need to know a basic understanding of the SQL NoSQL part, basically the database understanding we need. And this part is very important, the research part that comes, the natural language processing and the machine learning models, and basically some other part of communication, social media mining, all these things are needed, like are recommended to a data scientist. Okay, let's move to the next part. And these are the application of the data science. Basically, a data science project, the data science field, you can apply it wherever you want. You can apply it for travel, for marketing, healthcare, sales, credit insurance, automation, social media, everywhere. So, okay, let's come to the social media. Everyone is familiar with the social media. Can anyone tell me like one use case, data science use case of a social media where we use a data science thing or a machine learning thing in social media? Anybody wants to try? Yeah.
Like in
Come on.
engagement of users, like what they want to prefer to see more. Like they are going for the videos, like short reels. So we will show them the
Mhm.
reels more.
Definitely, the
Similar to this.
algorithm, engagement algorithm, definitely it is a use of machine learning like use case. Cool. And also, can anyone tell me one example of this healthcare? Like healthcare industry is actually looking very forward to the all the data scientists and the data science engineers, all that. So any use case of healthcare that you can think? Anyone? Okay, so let me tell you, like we can actually create this kind of projects like very easily because the data is available. So one of the trending healthcare thing is breast cancer. Okay, now if you in a Google, if you look for the breast cancer data set, you will get an immense number of data. You can get the image data, you can get the data in the tabular format. If you get the data, you can actually, by using machine learning, you can actually predict that for a new patient, whether like he or she might be affected in that particular disease. So not exactly like breast cancer is very trending, like trending of all time, but any kind of cancers, any kind of disease, diabetes disease, you can actually predict by the data that whether a particular patient has this disease or not. So this kind of prediction are like really happening, and researchers of all over the world are trying to create like a project. Like project means trying to create a particular software or app that can accurately predict whether someone have that particular disease or not. And we can also create this kind of project very easily. Like by the end of this, like the data science course, we can like definitely create something like this kind of disease prediction that might help with the medical field. It's very easy. So basically, these are all the use cases of the data science. Now, moving forward to the next slide.
Can you share one use case of automation?
Automation basically is already written self-driving car. So what's comes in your mind when you hear this term self-driving car? Which company? No one knows? How's that possible? That guy's firing like hell.
Elon Musk.
Elon Musk.
Exactly. Basically, the Elon Musk Tesla. So Tesla, the self-driving car, the self-driving algorithm is based on a particular machine learning stuff like reinforcement learning, whether the machine will learn at the real time that which decision it needs to make. So this is like one automation. Another automation that is pilotless aircraft. So if you know a little bit about the aviation, you will see like in a like an aircraft, like a huge thing, 80% thing is automated. A pilot is a someone who can monitor everything, and based on some situation, and he or she can like he or she can change it basically. But airplanes are actually runs more than 80% of stuff by automating, and industry is trying to make airplane is so automated so that we don't even need a pilot. For example, this self-driving car, the vision is that we don't need a driver to drive the cars. The cars will drive automatically, and it can It should take the best decision in a particular case. So this kind of automation, like are the comes under the vision of the data science world. And this credit and insurance risk, fraud and risk detection, I guess this is like a very like this is like one of the wildest thing that is happening. It is very easy to create, and everybody wants this credit risk insurance. The company I work here also, like and we also work in a similar use case of the credit risk insurance. So basically, it detects like whether a particular company or a particular person are worthy of a credit points, whether if someone demands money, someone comes for a loan, whether we can really give that particular loan to it. This is all about the credit risk insurance. So these are all the different use cases that we have. Oops, sorry. Okay, now career opportunities in the data science. So we have different kind of roles once you are in the data science. The first thing is data scientist. So by like the whole time what I was like trying to deliver, that was only for the data scientist. Basically, data science, if you are a data scientist, then you need to know pretty much everything of each and every part of a data science lifecycle. Now, let comes to the comes to the data analysis part. Now here, as per the name says, you need to bother about the basically the EDA part. You need to create some really cool charts, some really effective charts, so that you can show to your client, and your client can make a good decision based on the historical data. Now, if you are a business analyst or business intelligence analyst, you need to understand the business problem, and you need to think, and you need to create a possible solution that that you can pass to the data architect, data engineer, and the machine learning like model researcher, so that they can create that particular idea that you are proposing. So basically, you have a business problem and you need to find the solution. You need to think about the solution, and you need to pass it. Now, data architect, data engineer, basically for both this job profile, you need to be very good at databases. You need to be very good at SQL. You need to manage. You need to yes, you can say you need to manage the data, and you need to store the data in such a way so that when you pass to like a data analyst or a machine learning researcher, so that they can use the data in a proper way, and they can like if it's a data analyst, they can create proper EDA, proper charts, and if it's a machine learning engineer, they can create proper machine learning model. And same for the database administrator. Like basically, you are gathering the data from the database, and the database is a huge amount of data. Basically, data architect also like manages the database. Data architect generally is a very like kind of senior position after data engineers. Like generally, a database administrator and data architect, these are actually senior position where you have to handle the whole database. You need to ensure that each and every data, whether it's relevant is or is not relevant, needs to be present in your database, so that when you need, you can retrieve the data from it. So, and also like one more job role that is not given here, that is machine learning engineer or machine learning researcher. So basically, your job would be that create a very efficient machine learning model that can predict your, you can say like your use case very accurately, like the output that is supposed to take, you can deliver it. So accordingly, you need to design your machine learning model. So these are the different like opportunities that is currently there in the industry for the data science. Now, moving forward, now these are the some advantage, disadvantage, or pros and cons of the data science. Advantage is definitely is in demand, like everywhere. It can, like, this is the era of the craze of the artificial intelligence, where like the data science, the machine learning, these things, like everyone is fascinated of this particular term. So it has a huge demand, and it has a huge number of positions and highest paying careers, definitely, and prestigious, although like highly prestigious. I believe every job is equal prestigious. So let's ignore that. But yes, and it is versatile. Like if you join as a data scientist, you have to do a lot of work. You have to look at the data visualization. You have to look at the data, when you the data cleaning, data sanity part. You need to look at the machine learning modeling part. You need to check the outcome. You also need to understand the business problem. So basically, you have to do a lot of work. It's not like you're doing one work again and again. Well, although it's less hectic, like if you do a same work again and again, but that's not the case of a data scientist. Now, disadvantages, like you can say like a blurry term, like everybody knows like data science, data scientist, but most of them doesn't know like what is the exact job. Like there is a thing like data analyst and data scientist. Like a huge number of people think like both are the same because both knows the same skill, but there is a huge difference. So we need to know, like before starting a new step, we should have a very good knowledge regarding that. And mastering data science is nearly impossible. The reason is data science is huge. You can't even think how many tools, how many softwares, how many things, how many different kind of use case you need to learn. So if you think that one day like you can get everything covered, this is very close to impossible. So this is a thing. And also large amount of domain knowledge required because like you need to check a lot of stuff, and arbitrary data comes with very unexpected result. Now if your data is not like properly sanitized, not properly cleaned, and not relevant, then you will get a really bad result that might go for a disaster for you or for your company. And problem of data privacy. Now, again, this is the training problem that I have already shared, that data privacy, everybody wants to steal your data. Whether doesn't matter, or whether it's a relevant data or it's irrelevant data, because a particular data might be irrelevant for me, but might be very relevant for a particular company. For example, if I'm saying to my friend that I really want to buy a TV, or I really want to buy a smartphone, then I forgot. This data become irrelevant for me after some time. But this piece of data is very relevant for Amazon and Flipkart. So they will keep showing me some very new phone with very cool features so that basically they want to buy me a phone. So these are basically the pros and cons of data science, you can say. Now, okay, we are going to jump into the data analytics part. Again, I will talk about a little bit of the data analytics. So before that, anybody has any doubt regarding anything like whatever I said? Or if it's good, then we can proceed to the data analytics. Okay, looks like it's fine. So let's proceed to the data analytics part. Now, data, like what is data analytics? Like I'm sure like you have the idea, like what is the data analytics? Definitely a part of data science, and it is basically collecting, analyzing, interpreting the data. Remember, these three things are very important when it comes to analysis: collecting, analyzing, interpreting. Collecting, basically, you need to collect the data. You need to collect the relevant data that you think it will help you. Then analyzing. You need to analyze the data for yourself. You need to understand the data very well first, and then interpreting. Interpreting means here you need to make understand to the particular stakeholder or to the client or to others what you have understood in a better manner, basically in the form of charts, in the form of graphs. So these are the fundamentals of data and data analysis. So where you have a database, you need to do the data cleaning, data sanity, you need to do. Then you need to do the EDA part, exploratory data analysis, and then you need to like tell it to your client or the whoever the stakeholder are. Now, for the data analytics, you need the skill set of basically one particular data visualization tool, which is the one of the best is Tableau, or for some people it is Power BI. Power BI is a Microsoft product, so it depends. So basically, if you know Tableau or if you know Power BI, you can actually easily switch to another like another data visualization tool. Microsoft Excel also supports a good amount of data visualization stuff. Like if you need basic data visualization, you can do it with Excel also. You need to know statistics. The reason, because you will be doing the data cleaning. And also, although feature engineering, the step, if you can recall, the feature engineering, this is not a job of the data analysis. Like for a data analysis guy, you don't need to do feature engineering, but in your in order to get a better chart, better visualization, you might need to find one or two features, and you might need to create some graphs with it. So that might need it. So for that, you need to know statistics, and again, you need to know Python, because again, the data cleaning, data sanity, this part you can only do with Python, and some EDA part also you can do with the Python. Python means the core Python and also the Python libraries. So these are the basic, like all the skill sets that need to be learned in order to come in the data analytics world. Okay. Skills that needed. Oh, that's what I just said.
So actually, I'm having one doubt.
Yes, sure.
So what is DAX, sir? Actually, I heard a lot of things about it, sir.
So, sorry, what is?
DAX.
That means like, can you write it in the chat?
Okay.
Probably your voice is a little breaking. Okay. Oh, okay. Jax. Oh, this is again probably it is probably not a tool, but it is again it is something that gives you different kind of graphs. It mostly used probably for the kind of like time series data. Time series data means where the time is involved. So it might be a new tool, or probably some particular company that use it the more. So basically, it actually used for, I also have heard about, and it is definitely used for something related to the finance. Either it would be a stock, or it would be probably for the currency range. For that thing, it might be used. One of the data visualization tools that you can say. Okay. So yes. Any more question? Anything else? Let me know. Okay, fine. So basically, these are the skills that we be needed. Again, the same thing: Excel, critical thinking, Python, or R programming. Okay, I haven't tell about this R. R programming, like when we don't have like in the early stage of data science, it actually started with R. R is very similar with Python program, but Now, currently we have Python and we have very rich number of Python libraries. So we actually don't need R. R programming is actually we used to do the statistics. Like R is very comfortable with statistics, but right now Python is also comfortable. So right now we can actually exclude R. We can only go with Python. So, and also data visualization, there are multiple ways, presentation skill, that is very important for a data analysis guy, and also machine learning. Machine learning is actually kind of optional. If you are interested in the machine learning part, then you can actually create the better graphs, because once you have some basic machine learning output, you can actually create a very good prediction graph. So for that also, like, it is a good thing that a data analyst guy also knows basics of machine learning. Okay, moving forward. Okay, so again, this is one of the like use cases or different applications of the data analysis, where you can see basically, again, just like data science, because since data analysis is a part of a data science, you can use it everywhere, literally everywhere. You can use for financial service, you can use for recommendation engine, support ticket analysis. Like many of you are very familiar with the support tickets. Must be some of you are like spending your months to analyzing, to solving different kind of tickets. So, and basically everywhere you can actually use the data analysis. Now, in the career opportunities, in the data analysis, like a data analyst, definitely. And or we can go for also business intelligence analyst or business analyst. The job role is basically the business analyst. That it can go for, and anything. Like, this is a funny thing. Whatever job role that comes with analyst, okay, whatever job role comes with analyst, you can apply for it. So there are a really very fancy name for the analyst. There is a job role for only analyst. Analyst was alone a job role. So for any job role comes with the analyst, we can apply if you have these like knowledge. Now, again, comes with the pros and cons, and these pros and cons also very like similar to the data science. So better decision making, definitely. Like once you have all the charts that is present in front of you, it will be very easy to understand like what will be your next step to do, what will be your logical step to perform in order to gain the maximum outcome. And more accessible automation. Okay, this thing. Can anyone tell, like in data analysis, what kind of automation is possible? Anyone likes to answer? What kind of automation is possible? There is no machine learning algorithm that is widely present. Then what kind of automation is might possible in the data analytics sector? No one? Okay, let me answer. So this automation is about inserting the data, real-time data. Now, what is real-time data? For example, let's say the stock market. And when you have a time series data means data with the timestamp. Means for every second you are getting the data, and for every second the data is changing. So this is time series. Now, for example, let's say you are creating a stock market thing, any stock you find, and you are getting this kind of graph. Okay, but this graph is a very particular for a time limit, right? Let's say for a time for 12 p.m. to 6 a.m. This is the data. Now this graph is known as static graph. For example, like it won't change because the time is fixed. Now let's say you want to create a graph, something like when the time is moving, you need to see like how the graph is also moving. Those graphs are known as dynamic graph. So by using dynamic graph, you can actually see the graphs in the real time. Basically, you can see like if the stock price goes high, the graph will go high. The stock price is low, the graph will go low. So these kind of data with these are known as also live graphs, or the particular term is the dynamic graphs, where when you insert a new data, the graph will also change over. So this is all about the automation in data analytics. Again, predictive modeling, good to have. Personalization, this is very important because uh, you need to give customization or more personalization to your stakeholder or to clients so that they can understand the data in a better way. And attention and loyalty, forecasting. Forecasting again comes a little bit about this predictive modeling because forecasting and comes with the prediction. Now the cons. The first thing is very, very important and like very, I can literally feel every day, lots of patience. Because what happens whenever you ask for a data, at least for first and second time, you never get a relevant data or a good data that you can immediately start working on. You need to analyze, you need to wait, you need to ask for the relevant data. And once you get the relevant data that you can think, then only you can start with. So patience is needed, definitely. Limited executive size. The thing is, if you take that data, if you take a data of any particular use case, you can actually perform, you can actually create graphs with a limited number. For example, if you use Excel, Excel has a limit. Excel has a very limit of creating graphs. If you put literally a 1 million, and Excel might can create a graph on it by after taking, for example, an hour, it might create a very good graph. But let's say if you have a huge data, let's say 10 million data, okay, you can't cover all that data. And one more thing, like it also depends upon the visual. Like if you have less data, like for example, try to relate if you can. For example, if you have 500 data, okay, over here, then you can get this kind of graph very well. But let's say if you have 1 million data, then your graph will look something like this, and it has 1 million data. Now, just look, it is very hard, it is very difficult to understand or difficult to get some information from this graph because this graph looks very same. If you have a ability to zoom in, then you might see this kind of thing and you can analyze from that. So this thing actually is a big problem. And one of the best way to solve it by using dynamic graph. So that you can understand this thing better. Lack of alignment within the team, that is like a pretty basic problem. This is, we don't even consider this as a problem. We actually put it in a legitimate step because alignment is an issue. And privacy concern, again, the data privacy, like whatever you are creating, whatever data you are getting, you need to preserve it very well, otherwise anyone can steal it and they can do a better job before you. So definitely privacy is a big concern. So that's all about basically the data analytics part. Now let's try to understand difference between the data science and data analysis. So this is like one chart. This is actually a very limited chart that is given. After a slide, I have a very big chart, very big, you can say, Venn diagram stuff. Okay, whoever is doing that, please don't. Okay, so basically this is the Venn diagram. Like I hope all of you know this a word Venn diagram. Like in our like +2 or +12 maths, we have the set theory and where you have the Venn diagram. So This part, that means you need all the skills, all three bubbles skills. Basically, you need this part. That means you need the skills of this bubble and also this bubble. And this part means you need the skill of this bubble and this bubble. This part means you need the skill of this particular bubble and this bubble. So this is how basically a basic Venn diagram works. And you can see like big data analytics, basically again, that comes with database stuff where you have a huge number of data and you need to analyze that. You need a software tools. You have a big data part. Big data, basically a huge number of data that is present in your database administrator. Um, and again, you need to do data analysis, you need to understand, you need to finalize the machine learning algorithm, and after that only you can like come with a proper solution. So okay, this is actually, this is not exactly a difference between data science and analysis, but the basic difference is like data analysis, like you need to, you can stop after the analysis part. After analysis, you can hand over your data to the machine learning engineer or to your next step, and then the whole like the data science pipeline that needs to be occurred to get the proper prediction. Now, the future. So this is by survey says by 2025, estimated that 463 exabyte of data will be created each day globally. So that means the like this is huge. Like we are currently dealing with the terabytes, like or probably one step up of the terabytes. And this exabyte is like a whole another level. And currently like the data, the amount of data that generating all over the world every day, like that is beyond our imagination, because that is relevant data, irrelevant data, noise, all the things. If you sum up together, that is beyond our imagination how much data we are generating. The funny thing is, we don't even know an individual guy how much data he actually we are generating in a single day. Try to find it out. This is a small task I'm giving. It's a very interesting thing because I did it the same. And you will get to know, like you as a person, how much data you are creating in one day. The first basic thing, you can actually check with your browsing history. You can actually check how much browsing you are actually doing in a single day. So from that also, and if you just Google it, and if you read one two article, you'll get to know that what a big amount of data you are actually creating without even knowing it. So again, let's come back to the future. So basically, the popularity of machine learning, like increasing of like the data scientists, the growth, never-ending growth, emerging source of data, like we have data everywhere, and the problem handling with data. These things, like day by day, the requirement is becoming high. It's very much needed every day, and probably in 1 and 2 years it will be more than double. Like it is actually increasing like 2x, 3x, 4x kind of stuff. So this is all about the future in a little nutshell. Now we will again speak about a little bit of life cycle, and this will be the last part of my presentation. But before that, again, let me take a pause and let me ask you that do you have anything, any question, anything you want to ask? Please go ahead. Okay. Okay. Looks like it's still good. I hope all of you are with me, right? Fine. Now let's move to the data science, well, basically the whole the life cycle. And yes, this is the diagram that I wanted to put over here. And you can see like there are 4 different stuff like communication. Sorry. we have communication, we have statistics, we have programming, we have business. Okay, so these are the four fundamental stuff that, like, these are the four fundamental domain that we know, and how actually these are all connected. And here our data scientist basically lies. This is a kind of a little advance of Venn diagram, but basically by looking at it, you can understand that this is where you need all the skills. You don't need the skills totally, but at least you need to have proper understanding of all the skills. So you can look at it later. There are multiple stuff, and those who are working in any domain, everyone can read it because it actually takes pretty much everything. Okay. Now, again, the data analytics roadmap. So what we have planned for this course for the data analytics, like it will start, we probably from the next week, we will start with Excel. In the Excel, we need to know the basic Excel functionalities. So Excel is not exactly only needed for the to store the data in a tabular format, in a table format. Definitely not that. We can do every arithmetic stuff. We can do data visualization. We can actually create something called pivot table. We can create. We can also do some data forecasting. We can also do some regression analysis. All these things we will cover in the Excel part. Then after that, we need to know SQL. Now in the SQL, we at least need to know the basics of SQL, where how we need to like retrieve the data from the database. We need to know some basic SQL commands. For example, let's say how to create a table in a particular database, how to extract the table, how to insert some data inside the table. These things we need to understand, uh, and by using SQL, we can use. By the way, the full form of SQL is structured query language. Those who are very new. And after that, we will come to the data visualization part. In the data visualization part, we will cover the Tableau, we will cover the Power BI, we can cover like one of the tool, like very detailed. I have a plan because personally I use Tableau a lot. So I will cover Tableau in a more detail. And if the time permits, then we can also cover Power BI in very detail. But you will understand, you will see, like once you are comfortable with one data visualization tool, every other data visualization tool you can understand. Like by looking at the option, by looking at all the all the icons, you can easily understand like what particular stuff it will do. Now, after that, once you are done with these things, we will come to the Python programming. Python programming, this is basically the core Python programming that we will start with. It comes up DSA, it comes up the basics of DSA, and also it comes with the OOPS. So basically, DSA stands for data structure algorithms, different kind of data structure. Like we are basically dealing with the data. So we have to be very good into the data structure part, and also we need to very good of this OOP, or we can say OOPS. Any idea what is the full form of OOPS? I hope those are from coding background.
Object-oriented programming.
Object-oriented programming.
Definitely, object-oriented programming. So Python is object-oriented programming from the very beginning. Like I will tell you the Python history, and I will tell you later why it's actually known as Python. And if you don't know, it will amaze you. Let me tell you. So we need to understand at least the basics of OOPS, because why we need it? Because once we are done with the basic Python, we will come to this Python extended libraries. And it is the first library we'll see the NumPy. Sorry, this is wrong. Basically, NumPy, there is no A, NUMPY. This is NumPy. We will come to pandas. We will come to matplotlib, and also like we need to know several libraries in details. There's a library called SciPy. SciPy stands for scientific Python, that is used for statistics. We need to know something called Seaborn. We need to know something called Plotly that is used for interactive data visualization. So, and also we need to know something called scikit-learn that is used for machine learning modeling stuff, the predictive modeling. There are multiple like Python libraries that we will be knowing, and I'll love to share all of it. Then we'll come to the data preprocessing. Once we are familiar with this NumPy and pandas, we can actually do this data preprocessing step. And after that, we will come to the statistics part, because after data preprocessing, actually some of the data preprocessing units are also needs the help of statistics. So we need to know very well the statistics, because this is the fundamental stuff. I hope the basic statistics one can recall at least these three terms: mean, median, and mode. So we will start with mean, median, and mode, and we will go to the all the inferential statistics, descriptive statistics, how basically the standard deviation. What is the standard deviation? What are the different probabilistic statistical function? What are the, you can say, the probabilistic distribution? Like there are very famous distribution called normal distribution. These things we need to know, and also we need to know about the hypothesis testing, the regression analysis, the A/B testing, and there are lots of stuff. Statistics is very interesting. All you need to know a little bit of practice. And this is not like the math class practice. This is a very interesting practice with Python. Like we are not going to solve by hands. We are going to write some Python functions for the statistics. So this is pretty much for data analytics roadmap. Now, if you go further, then you need to come with the data science roadmap. And you can also see this part is basically the whole the data analysis. And once we are done with that, then we need to come with this machine learning modeling part. So once we are done with the statistics and the data preprocessing and all the stuff, we need to come to the machine learning part. This machine learning has a plenty number of algorithms. There are so many algorithms that is actually scientists are creating right now. There are tons of research papers that are available for different machine learning algorithms. And remember, each machine learning algorithm is a research material. Like if you want to know more, there is no end for each machine learning algorithm, because the world, across the world, like a huge number of scientists are basically researching on each machine learning algorithm that we're going to learn. Then after that, we'll come to the deep learning. Deep learning is a subset of machine learning. This is like one of the most advanced intelligence that you can think of. Then we'll come to AI. Basically, AI actually is a combined part of machine learning and deep learning. But there are some other stuff that not directly comes under machine learning and deep learning that we're going to learn into the AI. Then we will come to the NLP. NLP stands for natural language processing. You know, our like assistant, all the voice assistants like Siri, like Alexa, everything depends upon this NLP, because we actually instruct some thing with our voice, and that device is understanding and getting the result. So these are all the NLP use cases. Then after that, we have time series modeling. Time series again, like when a data has a timestamp, when a data is changing, depending upon the time, those data are really hard to handle it. So we will learn how we can handle this time series with deep learning. These are very interesting things. Yes, we need to learn a lot, but when you'll be implementing this time series with a deep learning, you will see like you can actually do wonders. Like people does wonders with this deep learning time series models. And after that, we have project. So we might have like we have one single project at the end that will be the final project. But in the meantime, to understand, we need to do some little projects, some small projects for your understanding. Like for example, we can actually do some prediction. We can actually do some like card price prediction, house price prediction. Let's say we have bunch of these house, these are the prices. Now for a new house, what will be the price? Or for example, after some time, after 1 year, what will be the house price? This kind of different kind of prediction we can do. This might seems a lot, but once you are done with at least this machine learning part, we can actually do different kind of projects over there. So this is the pretty much roadmap for data scientist to be a data scientist, I must say. Moving forward, what are the tools required? Tools. Now, yeah, this is one of the perfect like diagram that I can find for the data science tools. Now you can see how many tools we need to understand to gather the whole data science stuff. But fortunately, we don't need to know everything because, for example, just see, for languages, there are multiple stuff. This is Java, this is JavaScript, this is Julia, this is R, this is Python, C Sharp, all these languages. Yes, all these languages are good to know, but we mostly 99% of time we only need Python. Okay, for development tool, we have see Jupyter, we have Microsoft Visual Basic, we have Art Studio. So and also we have multiple development tools, but we need to know two or three very we need to know at least this Jupyter notebook very well. And also when we'll implement the deep learning stuff, we need to know either PyCharm or Spider. So two or three tools for the proper deployment is enough. Then the data integration tool. So these are all the databases, these are all the servers. If you are a data engineer, then this is what you need, you need to know completely. Now, data exploration and data visualization. If you are a data analyst, then this is your world. You need to know these tools, not everything, but at least you need to know Excel, you need to know Tableau, you need to know like some other tools as per the requirement. And this one, this is actually one of my favorite machine learning libraries. This library is known as TensorFlow. TensorFlow is created by Google. So the Google has a sub branch called Google Brain, one of the advanced team in all over the world in the field of machine learning. That Google Brain actually created this TensorFlow library. When we're going to use this deep learning stuff, we have to use TensorFlow. There are two libraries that is present. One is TensorFlow and one is PyCharm. PyCharm actually created by Facebook and TensorFlow created by Google. And this is my favorite. Also, we need to know this XGBoost. This is a very complex and very important and best giving accuracy algorithm that you can ever find. This thing is basically the Anaconda Navigator. So inside Anaconda Navigator, once you install, you can find Jupyter, you can find Spider, you can also find RStudio, and you can find many stuff. And these libraries, XGBoost library, these libraries, you need to install inside Anaconda in order to take it, in order to use it. Now, basically, these are part of the machine learning and the deep learning. And again, these are the big data part. Again, the data architect, data administrator basically handles this stuff. So this is a completely different domain. This is not a sub part of artificial intelligence, like how to manage the data. This is a different domain. But again, at least we need to know SQL for that. So these are the like all the tools. Not even all. There are multiple tools like there are like that we can't even imagine. But these are the most of the tools that we need to use. So moving forward. Now, again, okay, this thing I already have mentioned, like architect, all the stuff. Basically, these are the same. And yes, the top recruiter of the data science, definitely Google, Apple, IBM, Amazon. JP Morgan, Microsoft, and basically right now every software industry, every software company wants data scientists. Google, like Apple, Amazon, these are like the very early stage recruiters. That's why these companies are very good, and these companies develop their data science and machine learning algorithm very well, so that basically we are using every day right now. So, okay, one question. Try to answer. Amazon, what kind of data science application Amazon use? Can anyone tell me?
AWS.
AWS is not a application. AWS is like a cloud, the biggest cloud service provider that you can think. I'm saying what use case, what application that Amazon use, data science application. Netflix also use the same thing. Means different version, but Netflix also use that. Flipkart also use that.
E-commerce.
A little more specific. Okay, this is called recommendation engine. Netflix recommendation engine are known as the best recommendation engine that is ever like created. Okay. After that, Amazon comes, Flipkart comes, and Google. So like the recommendation, Google is only running for recommendations basically. So recommendations are very important for these company, and also like if you are selling some product, if you are selling anything, recommendations are very needed. So, and like if you consider like all the like big companies, small companies, data science requirement is everywhere. Now, top recruiters for data analytics, again, basically all companies like whoever needs a data scientist, again, they need a data analyst too, because again, data scientists needs to know everything, but a company can't rely on one single person. So that's why data analysts, the job are like, you can actually find more analyst job than data scientists, basically. And these companies are like one of the pioneers for that. Accenture has that job role, like only analyst. Even my company has also that job role, only analyst. Okay, certifications, like if you want to do the certification from the marketplace. Now, this marketplace means all the different vendors. So someone literally said that AWS. So Amazon was the first cloud provider like that came in the market. Amazon Web Services. So AWS is the biggest cloud provider that you can find. After that, you can like the Oracle certifications. Oracle basically the database administration company. IBM Data Science Professional Certificate. I guess you can find it on the Coursera website. SAS Data Science certificates. These are also you can like you can do if you need. Like these are all the external certification that you can do. But also one thing is not mentioned: the Microsoft certification, a very common Microsoft certification that you can also do. Where remember, like this certification thing, like there are many kind of certificates that you can find. You can even find some certificates after watching a video, like let's say 2 or 3 hours video, you can get a certificate. So those certificates are not actually useful. So all these certifications, you need to pay for the exam. You need to give a particular a test after some certain time, and then only that vendor directly from Amazon AWS will give you the certificate. Same for the Microsoft. The vendor will give you the certificate, and that certificates actually having that certificate is a very big deal for you. But there are plenty of certifications that are available. And again, this course, like the eligible, and this course is designed in such a way so that everyone can understand. And so it will help for everyone, starting from non-tech, because we are actually starting from Python. So Python from the very basics of programming language. So if you are not from a technical background, that's not a problem. You will start with from the very scratch. And if you are a fresher, then I'm hoping that you know the basics of programming language. So after that, we can definitely go for. And if you are a very experienced guy or a tech guy, then definitely, at least for the first few sessions, it will be very easy to grasp it. It will be very easy to understand, and those the assignments that will be given, it will be very easy to do it also for you. So this course is designed in such a way so that we can cover the larger audience. So we can cover everyone, and everyone will get benefited from it. And yes, now let's come to the assignment. So this is a very interesting thing. So basically, try to do it. Try to gather about information about 5 companies that are hiring for data science in your domain. So the best thing, you can start with LinkedIn. I hope all of you have a LinkedIn account. So you can literally search there data science or data scientist. And if you search, you will see there are plenty of opportunity. You can't even stop scrolling. How many companies they are actually, how many companies are looking for it to get a good data scientist. So just go through it and came up with top 5 companies, like just not top, any 5 companies that are currently hiring, and that will also help those who are actually looking for a job change, looking to for a job switch. That will definitely help. And that's all. That's all from my side. That's all for today's introductory session for the data scientist, to become a data scientist or to become a data analyst. And now it's your turn. You can ask me anything regarding this course, regarding the job opportunities, regarding the market. So if you have anything, to ask, and about this course also, like how we are planning, if you want to know something more, these things you can definitely ask. So that's all from my side. So if you have question, please go for it.
So I have one doubt.
Yeah.
So actually, it's regarding means actually there was my friend, and he has done already this course, data analytics. So he was just applying for multiple companies over the LinkedIn. So sir, actually many times he got a call from the only consultancies. So sir, what you want to say about it means it is my wish, if I want to apply, so I should get a directly company calls. So why this consultancy and all like this is happening? So
Okay, so do you know what actually consultancy means?
no, sir. Actually, means according, I don't know lot of things about it, but the basic idea is that consultancy take a charges from us, and then after that they just want to hire us like third party and all. We say is that. So only the bit
No, no,
ideas I.
no. That is a different kind of consultancy. See, the consulting team, the job of the consulting team is to understand the product and give the demo to the client. Like, I'm very generalizing. There are different part of the consulting. Okay, now think, if you want to give a demo to a client, you need the analysis, you need the proper analysis of a graph. So if you are applying for a data analyst, and if a consultancy company whose main job is consulting is reaching out to you, so it is obvious because they need a guy who has a proper analytical skills.
Okay. Okay, sir.
Okay.
Yeah.
Perfect. Okay. So others, any question?
Sir,
Sir, it is mandatory to certified from IBM, from AWS.
No. Certification is not mandatory. Certification will
Okay.
only help. Okay, this definitely not mandatory. Yeah, Manish, you was
Okay.
asking something.
sir, actually my question is, I'm basically from banking background. So my simple question is, can I apply for as a fresher or as an experience?
So if you're in a banking background, can you tell me a little more about your banking background and how long you are here?
Sir, I'm from 10 years banking industry experience, and both operation and business I'm looking for. I'm doing
Okay.
business and operation.
Okay, so definitely you won't get a fresher chance. Definitely, you are way more experienced, way more valuable than a fresher. That's for sure. So, see, since you are like a banking industry, so that means you must have deal with a big amount of financial data, financial risk, financial fraud that you can definitely you can understand because you spent 10 years over there. So if you have the even of simple of data analytics skill where you can portray like whatever you think to the client, to the customer, or you can advisory, all the advisory role. So I guess that would be like more like you will get more value out of it. And value I am talking about money. You will get more money about it.
Sir, second question is there any opportunity in banking industry also? Because you mentioned only tech industry like Accenture, TCS. So there is no mention in a banking industry.
Banking industry, yes, like see, analysis, every industry needs analysis. So your banking industry that definitely have needed analysis. But since actually I'm from the tech, I'm from the software stuff, so that's why
Oh.
I prefer the tech. But banking industry, every industry needs the analysis. So banking industry comes under same because your
Okay.
bank must have giving to loans to someone, and also they have a tension how to recover it.
Mhm.
It's a normal thing, so definitely it's needed.
Okay. Thank you, sir.
Hi Manish, Guru here from Chennai. So I have mentioned earlier my job is entirely different one. It's a facility management here. So how good will it be manageable for me to get into this administration?
Sorry, can you come again?
No, I'm in a facility management field, so it's an entirely
Okay.
different field. So I don't
Okay.
have the data things to be calculated. So how good will this data analyst help me to get to change in my career?
Okay, so like how long you are in this field?
10 years, 11 years, 11 plus years.
Okay. Okay, that's a big commitment. Okay, so so actually for your field, I am actually not about, I'm not like familiar about much about this thing. So just bear me some time. You can connect me with WhatsApp. I need to check and I need to tell you. But let me tell you, that data analysis is something that is actually need everywhere. But the proper thing, let me check once and then I will get back to you.
Thank you. Thank you.
Okay? Yeah. Please connect me on LinkedIn or I probably over mail. I might share the number. Please, that's my WhatsApp. Please ping me. Then I'll try my best.
Okay. Okay.
Okay. Anything else? Any more questions? Please go for it. Okay. So seems like no questions. Okay, so if everything is good, then just great. And if it's not, then you can ask me. You can connect with me at like anytime. So, uh, so just a minute. Something came in. And yes, yes. So I will share my number. So wait, let me give it here only. Okay, what I'll do, like I will write a mail to all of you, and but there I'll share my credentials because I don't know if I can directly share my number to you right now. So I'll write a mail, and the team will might share my credentials.
Yeah, we will share the number with sir
Okay,
later
okay.
on. We'll just discuss internally and share it.
Okay, 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 sure. Um, okay, so if everything is fine, then we can wrap it up for it. We are already 2 minutes ahead of time. So thank you everyone. Thank you so much for joining. I'm hoping everyone to see in the next weekend. We will start with the Excel. That is will be your first step into the data analytics field. So hope to see all of you there. Okay, bye everyone. Good night. Sweet dreams.
Thank you. Bye. Good night.
Good night.
Thank you.
Thank you all.